Now, in this video, we will going to discuss about take up one more problem on a bar of problem number 72. A bar of cross section 10 mm by 10 mm is subjected to an axial pull of 8,000 Newton. The lateral dimensions of the bar is found to be changed to 9.9985 mm into 9.9985 mm. If the modulus of rigidity of the material is 0.8 into 10 to the power of 5 Newton per mm square, determine the Poisson's ratio and modulus of elasticity. So what is the longitudinal stress? Longitudinal stress is sigma P by A. You know that P is 8,000 divided by 10 into 10, which is the area of cross section, which is 80 Newton per mm square. As we know, as we want to find out the Poisson's ratio, so naturally we should have the lateral strain. So what is the lateral strain, which is sigma by m into E? So what is sigma? 80 by m into E. So what is the lateral strain? Lateral strain is nothing but also lateral strain is delta D by D. So here we have delta D is 10 minus because the original width is 10 mm by the final width is 9.9985 divided by the original width, which is 10. So on simplification, you are going to get it as 1.5 into 10 to the power of minus 4. You substitute this value of lateral strain here. So that is in the above equation, that is 1.5 into 10 to the power of minus 4, which is equal to 80 by m into E. Now what is m into E? M into E will be equal to 80 by 1.5 into 10 to the power of minus 4. On simplification, you are going to get it as 0.533 into 10 to the power of 6. So now we need to find out what is the modulus of rigidity. It is ME by 2 into m plus 1. So what is G? Modulus of rigidity is 0.8 into 10 to the power of 5, which is given in the problem. ME we know that is 0.533 into 10 to the power of 6 divided by 2 into m plus 1. So you're going to get the value of m is equal to 2.33. But what I want is I want 1 by m, which will be 1 by Poisson's ratio 1 by m will be the reciprocal of 2.33, that is 1 divided by 2.33, which is equal to 0.4292. Once you get the Poisson's ratio, but what is ME? ME is nothing but 0.533 into 10 to the power of minus 6. But you know the value of 1 by m, which is 0.4292. But to m we know, which is 2.33 into E is equal to 0.533 into 10 to the power of minus 6. Therefore, Young's modulus E will be equal to 2.287 into 10 to the power of 5 Newton per mm square. So we're going to take up one more problem on the same lines. So you take a metallic bar of length 250 mm, width 20 mm and thickness 20 mm. Is subjected to an axial compressive load of 240 kN. So the decrease in length will be 0.5 and increase in width is 0.02 mm because it is the compressive in nature. Determine the linear strain, lateral strain and Poisson's ratio and Young's modulus. So we know the length, we know the width, length is 250, we know the breadth which is 30 and we know the thickness T is 20 mm. So compressive load of P 240 kN, which is 240 into 10 to the power of 3. So decrease in length delta L is 0.5, increase in width delta B is 0.02. So what is the cross sectional area? The cross sectional area is 30 into 20, which is equal to B into T, which is 30 into 20, which is equal to 600 mm square. So what is the linear strain? The linear strain is nothing but delta L by L, or the change in length or decrease in length by original length, which is delta L by M. So we know the delta L, which is 0.5 by length is 250, which is equal to 2 into 10 to the power of minus 3. So since it is a strain, you don't have the unit length. Now we go for the lateral strain. Epsilon lateral will be equal to increase in width by the original width, delta B by B. So delta B is 0.02 because it's already given in the problem. B is 30. So you are going to get it as 6.667 into 10 to the power of minus 4. So what is the Poisson's ratio? The Poisson's ratio is epsilon lateral by epsilon longitudinal, or the lateral strain by the longitudinal strain. So substitute the value of lateral strain and the longitudinal strain, which is 6.667 into 10 to the power of minus 4 divided by 2 into 10 to the power of minus 3. So you're going to get it as 0.33, which is the Poisson's ratio. So what is the linear stress? Linear stress is axial compressive load by cross-sectional area. The compressive load is P by A. So that is 240 into 10 to the power of 3 by 600. So you will going to get it as 400 Newton per mm square. So what is the Young's modulus? Stress by strain, or the linear stress by the linear strain, which is sigma by epsilon. You know sigma is 400 by epsilon, which you know, which is 2 into 10 to the power of minus 3. So then you will be able to get 200 into 10 to the power of 3 Newton per mm square. So this is how you will be able to solve this problem. Thank you.